Hey there, this is a short tutorial on how to plot the poles to planes using a stereonet. And the pole to a plane is a line that is orthogonal to that plane. So if we have a plane, for example, I'm using my hand here to indicate a plane. A pole to that plane would be, again, a line orthogonal to that plane. So like my finger right here. Okay, so that's 90 degrees from the orientation of the plane. And recall that a line on a stereonet is going to plot as a point. So in order to plot that, we're going to want to calculate that line that is going to be 90 degrees from the plane. So let's jump into PowerPoint and use our PowerPoint method to actually um, plot a pole to a plane. So here I am. I've labeled my stereogram already, poles to planes. Let's just choose a plane, 248, and let's say we're dipping 40 degrees. And the first thing that we're going to do is plot that plane, and then we'll plot the pole to that. So in order to do that, I'm just going to actually do what we have done in the past, which is I'm going to insert a little symbol right here. Oops, so that we can remember where we're plotting from. And I'm going to group that by selecting both the stereonet and the star, right-clicking and hit group. Your other option for grouping would be to hit Control G once both of those are selected. But now that we've got our reminder to always count in down from the primitive on this side, we can now rotate. And so when we select that, I've got my rotation options right here, and I can choose my strike, which is 248 to rotate. And now what I want to do is count in the dip. And what I'm going to do is I'm going to zoom in just to make life a little bit easier and hopefully easier to see. And again, my dip is 40 degrees, and I want to count down from this side right here where the stereonet is to insert that plane onto my stereonet. So I'm going to insert a curve, and I start from here, and I click, and then again, I'm going to go 10, 20, 30, 40. Click here, 40, 40, double up here, 40, 40, 40, here, here. And there's my plane. Just for clarity's sake, I'm going to actually make that a red line that you can hopefully see. And I'm actually going to make it a little thinner. I find that the default 2-point thickness is a little heavy. So I drop that down to 1 point. So here is our plane. I'm going to back out so that we can see this a little bit better. And I'm going to take the stereonet. I'm going to rotate it. And I'm going to just choose back to 0 degrees. Okay, I could manually rotate it using this. Or I can just choose 0. Okay, and so again, just for reference, here is my plane striking 248 degrees and dipping 40 degrees. Okay, now when you're actually plotting your pole to your plane, you don't actually have to re-rotate that. I'm just rotating it back so that you can see what the orientation of this plane should be. When you're actually doing this, I would not unrotate that stereonet in order to plot the pole. So I'm going to re-rotate it now just for us to see. 248. Okay, back to, again, just as if I was drawing that plane on there. And my pole to the plane, again, is going to be 90 degrees. All right, a line 90 degrees from the plane. And so in order to do that, again, I'm just going to zoom my stereonet in here a smidge so that we can see this nice and clearly. I don't know why it's doing that, but that's okay. And so here we can see that we have that 10, 20, 30, 40 degree dip. And so a line perfectly perpendicular, okay, is going to intersect along this line and recall that it is 90 degrees. So all we're going to do is we're going to count 90 degrees from here. But first things first, we need an actual symbol to represent that pole, okay, which is going to be a line. So I'm going to insert and I'm just going to make this a little dot. So I'm just going to insert a little round circle right here, and I am going to actually make this without a line, and I'm also going to make it red. And so there we can see that little dot right there. And so now what I'm going to do is I'm going to take that dot and I'm going to count 90 degrees from this line right here. All right. And so therefore I'm going to count 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. Okay, and so there it is right there. I'm gonna use my arrows, just move it, center it right on that dot because it was snapping to the lines. So I'll just unclick, and you can see 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. That now represents the pull to this plane. And now choosing my stereonet, we can see what this looks like by taking the rotation out, back to 0. Enter. I'm going to zoom back out so that we can see this. And there we go. We have a line representing that pull to the plane 90 degrees from our plane. So those are the technical aspects of how you actually plot that pull to the plane. We will see. You might be asking yourself, why am I doing this? Why am I plotting the pulls to these planes instead of just the planes themselves? There's a couple reasons. In some instances, it's just merely for presentation purposes. Let's imagine we've gone out and done a huge mapping campaign and we've got 300 or 400 measurements that we have for a particular formation and the bedding measurements in that formation, and we want to see what those look like, just graphically. We can plot those 300 or 400 lines, but it's going to basically make a really big mess on the stereonet, making it very hard to discern. Whereas 300 or 400 little points are going to cluster. We're going to be able to visualize the range in that data much more easily. So it's a very convenient method for presenting lots of planar data that is equivalent to each other. We're also going to be able to do calculations, angular and geometric calculations, using the pulls to the planes much more easily than using the lines themselves. We'll see this when we talk more about folding. We'll use the pulls to planes to actually calculate some fold measurements, and there are some other techniques or instances where we would want to use pulls versus those planes themselves, or at least on the stereonet, the lines that represent those planes. So that's a quick tutorial on how to plot pulls to planes, and good luck with that.